One of my favorite negative comments I've received so far is like something along the lines of like, wow, nice job. You did something that I can do with a couple lines of code and a single prompt. I think that's totally valid, but it's also missing the point that you don't just jump to step 10 in building agentic software. You take little steps, right? You do code things and you do build agents that you could do yourself very clearly, very obviously, right? But where things start to change is when you get, 2, 3, 4, 5 agents, you get 2, 3, 4, 5 different multi-agent teams working alongside you. Now you get to this point where you actually couldn't do what they're doing, right? And more importantly, even if you could, you don't want to, right? That's the whole point of agentic software, right? It's there so you don't have to do it. You stack enough of these up, you put your validators together, you put your orchestras together, you put your conversation flows together, and all of a sudden you couldn't do it yourself. And they're operating on your behalf, they're working in parallel to you. You want to create assets that work for you, right? In this video, we resolve 2 simple questions. What are my agents doing? Did they do their job? When you have 1 or 2 agents with simple prompts, the default AutoGen logging is sufficient. But as we grow our Postgres data analytics tool and start to add new conversation flows and new agent teams to help us manage and interact with our database like we never could before, we need to be able to understand if a team was successful or not. So how are we going to accomplish this? We're going to make 3 key improvements. We'll keep a simple yet effective record of our agent conversations, and then we'll build a simple way to spy on our agent conversations. We'll then build a validator pattern in our agent orchestrator to gain 100% certainty that our agents accomplish their task. This is really important because it enables our agent systems to be self-validating. Remember, the end game is fully agentic systems that require 0 intervention. Lastly, we'll update our orchestrator and our agents to use a store-like structure, something like Pina or Redux, some type of store management system, which will give us a centralized module for our agents. So let's get started. Let's open up VS Code. And let's recap our application so far. So just a quick high-level overview as usual. We're going to run Poetry, and we're going to run the prompt, give me all unauth users with jobs that took longer than 5 seconds. So I'm going to go ahead and run this. What's going to happen here is our agent system is going to load these tables from our Postgres database. It's going to generate the right SQL to satisfy the request. Then it's going to dump the response to a query, and as you can see here, it's already approved. Thanks to our work in a previous video, we have a good sense of how much this cost us. Looks like this one was 2 cents. And if we open up Table Plus here, we can see in our users table. So we're looking for unauth users. So, we're going to get a whole slew of unauth users. I want to show just how large this table is so that you can see that we're actually querying all these items and we're not getting a token explosion. Our GPT-4 context window is not being overloaded. If we go ahead and look at this results.json file, you can see here we have all users with the duration greater than 5 seconds. We can now, send this to a front end. We can now operate on these, and we can, take our data analytics pipeline from there. So if we look at the logs here, we can see that there's kind of a lot going on. Even just with the 3 agent system that we have here, there's a lot of mental overhead required to read and consume these logs, even with all the work we've done so far, right? So that's what we want to clean up. Real quick, let's go over the code of the current version and let's talk about what changes we're going to make. So right at the top here, same deal. We have the database URL, open API key. We have 1 capitalized reference here called table definitions that helps us build our prompt. We're using argparse to pull in a prompt parameter that we passed in here. We're then prefixing with fulfill this database query. We then pull tables from our Postgres database. Check out the previous videos to get it all caught up, but we're using some embedding techniques here, and then we're using a simple word-based approach here. Basically just match on tables that are specifically specified within our query, so users and jobs. Force our application to pull those tables into our prompt. We're then adding the table definitions we just fetched onto our prompt, and then we're using our orchestrator to build our agent system. And then we are running our agent system and we're getting back success and some data engineering messages. And then of course at the end here, we are dumping our costs. So we know how much it costs to run. That's the application so far. If you want to go into detail, check out the previous 4 videos. The series is really stacking up. We've done a lot of cool things and we have a lot of cool things ahead of us. So let's dive in and let's improve our logging system. I just want a quick shout out Neon, this is serverless Postgres hosting. Such a breeze to set up. I can't speak to scaling this out a ton, but everything I've seen so far looks really great. They've reached out to me twice just to see how things are going, probably automated messages, whatever, but I'm really happy with them so far, so I'm gonna keep using them. Of course, we have to shout out AutoGen again and everyone working on it. I think it's a great kind of framework for building out multi-agent systems. Okay, so first things first, jump into the orchestrator. And remember, the orchestrator is the kind of central hub of how our agents talk to each other. So we have this sequential conversation, which basically says agent A talks to agent B, agent B to C, C to D, D to E. So let's go ahead and build out a couple simple data models that we can use to direct our new functionality. So I'll create a new file called types.py. I'm going to import data classes. Let's create a chat from name to name, exactly message. And then we're going to have data class, and we're going to build out one more. And this is going to be our conversation success. We want to know if our agents ran successfully. Oh, switch out the class. It's going to be a bool, of course. We're going to have messages, costs. Then we want tokens, perfect. And then let's go ahead and just add our last message string. So this will be the last message in the list just for quick, easy access. Okay, so I'm a big fan of model-driven development because it kind of tells a story, right? You can kind of already see where this is going. So I'm going to start here with the simple chat. What we want to do is in our orchestrator, as our agents are having conversations and solving problems for us, we want to know exactly who's saying something, and we want to know who they're saying it to. And then of course, we want to know exactly what they're saying. So let's go ahead and implement this chat system inside of our orchestrator. All right, so our orchestrator now has a list of chats from start to finish that our agents have with each other. If we look through the code here, we can see we have a brand new send message function, which essentially wraps the AutoGen.send function. After the send, we're going to append a brand new chat. So you can see we have from agent name to agent name and the string. Pretty simple, pretty straightforward, right? Exactly what you would expect. And then during the sequential conversations and any other type of conversation type, we can open that up and we can see that inside of the basic chat, which facilitates agent A talking to agent B, and the function chat, which facilitates a function call. Inside of those functions, we're now just using that send message function, which will both send the message from agent A to B and record the chat that they're having. So we have one more special function here called spy on agents. This is exactly what you would assume. We loop through all of our chats and we use this cool data class.asDict. This will convert our chat type to a dictionary, and then we're outputting it to a file. And so that's basically it. We spy on our agents pretty much at any time during the conversation. I like to do it iteratively so that we have a log, even if something goes wrong and something fails, we still have a log of everything that happened up to that point. We have to thank our orchestrator for having a clean, simple structure, making this really easy to add. Let's go ahead and test out what our new agent flow looks like now. So now if we rerun that exact same prompt, we can see that it's generating the SQL, we're running the iteration 1, conversations are happening, great, and we finished. So now we're gonna have something really cool. We have this agent conversations.json file. So if we hop in our file, we can see, okay, so it looks like we're using append instead of write. So let me just quickly update that. So yeah, we're using open file name A, we want to use W. This will overwrite the file every time. So if we go ahead and just look at the final result here, this is what the final output would look like. We can see that we have from name and to name. So the admin is saying to the engineer, fulfill this database query, right? And we can go multi-line mode here. Fulfill this database query, basically pass in everything that you would expect. Here's a message. And then we have the from to, engineer goes to the analyst. And then when we have a function call, as we discussed in previous videos, we have the analyst talking to itself so that it can execute the function that it's been given. And then finally, we have the output of the function from the senior data analyst to the product manager. Let's go ahead and rerun this just so we can get a clean example. So, okay, cool. So we just reran, and this is the actual output of our file, right? So we have a list of objects, and our objects contain both the from, to, and message for each conversation. You can see how this can be really valuable, right? So in the current state of our Postgres data analytics tool, we only have one agent team, right? If we hop back up to the top level, open the code up, you can see here we're only operating on our data engineering team, which, as you know, consists of 4 agents that have their specific functionality. But you can imagine how useful this can be when you have multiple agent teams running, possibly in parallel, doing all sorts of different things for you, right? Operating operating on your behalf. Something like this, a clean, simple chat system where you can see who's talking to who's saying what, who's making mistakes, who's doing well. You need to be able to see that. You need insight into your system, and you're gonna wanna build something out just like this, something really simple. Of course, you can just like run the program and pipe it and do all cool sorts of bash functionality. That's really great, but we need to be able to come in, debug quickly, at a glance and see what's going on. What are our agent systems actually doing, right? We need these to run fully on their own. And when something does go wrong, which trust me, they will, especially on the journey to building these agentic software systems, we need to be able to come in and say, hey, what exactly is going on? Who's causing the issue? Because it will typically be just one agent, or there's going to be something wrong with the conversation flow that you're building, but it all will get revealed between the agents. Now we're going to answer another large question here, right? Let's hop back to our types and look at this conversation result, right? So the big question is, how do we know our agentic systems have solved the problem we want them to solve? And it kind of digs into this bigger issue of when building agents and agentic software, how much should you be using specific agents and LLMs and prompts versus just writing the code yourself? I think that this is a kind of a big question, and the answer really lies in, can you prompt it? Should you prompt it? And how much time will you save by using this system versus how much time will it cost? And I'm still kind of in that gray zone, really trying to figure that out. So I don't have the answer there, but one thing that we do 100% need to build is a concrete validation function. So what do I mean by that? Right now, if we hop into our agents, we can see here that our product manager is essentially responsible. Let's look at the product manager prompt. Our product manager is basically responsible for determining if the response is valid. But in reality, there's no actual check happening here. The product manager is just looking at the success message returned by the response from, let's find that function, run SQL, turn regex on. So you can see here, our run SQL function is just doing a lot of the work, right? So it's running the SQL query, it's generating the response in JSON format, and then it's dumping it to the result. And this is all getting run, if we hop back over to our agents, this gets run by our senior data analyst, right? So this response isn't really doing anything, right? It's just saying we successfully delivered, which is helpful as a signal to know that things are working. But we need to do better than this. This is not a sustainable way to build agentic systems. What we can be doing though, is still, while being explicit, just say and call the exact function that will verify that our agent team produced the result we wanted. So what do I mean by that exactly? Let's go to the orchestrator and build out a new variable here. So I'm going to call this validate results func, and this is nothing special. All we're doing here is building out a callable function, and we're going to pass it in, right? It's going to be optional, so you don't have to call it. And at the bottom of our conversation, instead of doing this like keyword check thing to see if things are going well, all we're going to do here is call this function, right? So we're just going to say validate whatever output our agents were supposed to produce, they produced it, right? So then that'll get returned, and let's go ahead and add this to the broadcast conversation as well. Say success equals self.validate. Just quickly do this here, else message here. Now at the top in our main function, we can, while we're building out our orchestrator, make sure that we need to pass in a success function, right? So a function that just says, hey, nice job, you did your job. So if we look at the database file, what we're really looking for is just some notion that this completed and has some results, right? So I'm literally just going to copy this. I'm going to add a quick function here where we're going to say validate results. And what this is going to do is it's just going to look for this file, right? So this is going to return a bool, and then we're just going to say if read, if content return true, otherwise return false, right? And we can of course just do something simpler like this, just return bool content. Whatever. The details are completely up to you, right? So we're going to pass this function into our build team orchestrator. We're going to make sure that this accepts this validate callable. Awesome. And then we're going to pass this in a parameter for our orchestrator. Okay, what's going on here? We're gonna make sure we call this validate results func. Awesome, so it's passed in here. Let's make sure we actually set this. Awesome, and then when our function's complete, they're going to call their validation function, right? So pretty straightforward, but ultra important. So now that we have this, we're actually just going to hop into our agents and completely just get rid of our product manager, right? the product manager isn't actually doing anything helpful for us. Definitely one day we could improve the product manager, make them, more useful in our agentic system. But, right now, this prompt isn't doing much for us. It's actually just wasting money and it's wasting time for us, right? So we have the validator function to explicitly say if our agent team was successful or not. And I think this is important. It's kind of tricky in agent systems to determine what you should try to have your agents do versus just code yourself, right? And I think a lot of building agentic systems is going to be riding that line of, should I do this or should I make an agent do it? And can I do this? And can I make an agent do it? And taking some of those opportunities to get practice building agentic systems and just have your agents do it. But also you want to be practical and you want to be pragmatic and results oriented so that you can actually get whatever you're trying to do done, right? Like in the end, I just want to know that they generated the results for me, right? So just check that, right? You have 4 lines of code, don't over engineer it. One of my favorite negative comments I've received so far is like something along the lines of like, wow, nice job. You did something that I can do with a couple lines of code and a single prompt. I think that's totally valid, but it's also missing the point that you don't just jump to step 10 in building agentic software. You take little steps, right? You do code things and you do build agents that you could do yourself very clearly, very obviously, right? But where things start to change is when you get, 2, 3, 4, 5 agents, you get 2, 3, 4, 5 different multi-agent teams working alongside you. Now you get to this point where you actually couldn't do what they're doing, right? And more importantly, even if you could, you don't want to, right? That's the whole point of agentic software, right? That's like the whole beauty of multi-agent systems on top of LLMs, right? On top of GPT technology, right? It's there so you don't have to do it, right? Right now I have to write these 4 lines. That's okay. This is going to help me build up this agentic software. But you stack enough of these up, you put your validators together, you put your orchestras together, you put your conversation flows together, and all of a sudden you couldn't do it yourself. And they're operating on your behalf. They're working in parallel to you, right? I really think that this idea of like parallel workers is so brilliant. You want to create assets that work for you, right? While you're also working, getting things done. So anyway, tangent over. So let's go ahead and run this. I'm gonna use the same prompt, who cares? And let's see what we get. So what we expect here is just to get a clean validation coming out of that function. So let's see what's going on here. So validate functions, fread, operation not readable. I put in the wrong flag again. So there's me just not paying any attention at all. So we're gonna use the R flag, this is the read flag, and let's rerun. I'm just too hyped off talking about agentic software. I'm just putting the wrong flag in, just coding like an idiot. So it looks like this failed because our senior data analyst has no one to return the function response to. So what I'm going to do here is just come into the conversation flow and add a little bit of logic to make sure that our last agent, you can see we're excluding anything happening with the last agent. I want to make sure that our last agent has the opportunity to make a function call. Okay, cool. So I have added this function called self-function chat. Basically what it does is at the end of our agent flow, so when we're running our last agent conversation here, so agent D to agent E, for example, when this agent runs, we're just going to check if agent B has a function that it needs to run. So agent B has functions, go ahead and run. Of course, save and then rerun our prompt. Awesome. So we can see that ran successfully. So we now have one less agent. That means fewer tokens coming in. It looks like there wasn't a huge change because the product manager honestly wasn't really doing anything. There's probably a joke about product managers I can make there, but there are some good product managers, of course. So great. So the orchestrator was successful. So now we have a pattern for operating and dealing with concrete results, right? So we know 100% that our agent ran, it did what it's supposed to do, and it was successful. Now that we have this validator pattern, let's go ahead and implement our conversation results to flow out of our agent conversation. So let's collapse and update this return type. We're going to do conversation result. Same thing here. So now every conversation is going to return this conversation result. Return conversation results and just build this out, right? So messages, great. Costs, great. Last message is string. Awesome. So we can get all that. Get message as string. Let's see what this is doing exactly. Not what we want. So what do I want here? So let's add one more property. I want to make sure that the last message we get out of there is always a string. So I'm going to say last last message, always string. And then lastly, just return string, self messages, last message. Great. So this is going to make sure that we always get a string here. Let's go ahead and place that there. Let me pull out the tokens. We don't need to run this twice. And then we can just place those here. Great. Cost tokens. Great. So this is all coming out as a concrete response type that we can later in the future use to chain agent responses and conversations together, right? Just like we did with our previous data visualization team. So let me go ahead and just pull this into the broadcast conversation, do that here. Now we're returning this concrete type. So let's go to the top and update this to be conversation result. And let's go ahead and add the type just to be super verbose about it. Great. And so now we don't have to call this separate get costs and tokens function. We can now just run this here. And just real quick, I just want to show this off. I don't know if you're aware, but Python 3.10, we now have this new match statement. So we can do match on this. We can say case, and I want the case where exactly, conversation result, success equals true, just the cost and the tokens here. So if success is true, run cost and run tokens. And then we can just bump this up and so I'll update this to data eng cost, data eng tokens. That works fine. And then of course we always want that case, default case here where we don't match anything so far. So in this case, I'm going to say orchestrator.name. There we go. So that'll be the team name. Bump this over and get rid of that. Awesome. So this is pretty cool. So yeah, this is a match statement. So basically we're looking for the case where conversation result matches this data type. So we want to see success is true. And then this is kind of magical. We're saying, give me a variable that is the cost out of this type, right? So that we can use it in this block context, right, in this block of code. And we're doing the same thing for tokens, right? So you can see that this variable doesn't exist anywhere. It's getting generated actually right here. So kind of really interesting, but yeah, match statement, really happy about this. Python 3.10 and above, definitely recommend you check it out. We can now pull our was successful statement up and out of these individual functions and just make the conversation flows more just about running, right? So let's go ahead and hop back here. And now if we were successful, I can go ahead and just print this here at the top. And if we weren't, I can move that here. So I can say this, orchestrator failed team, and then we'll print out the team, and then we'll say that they failed. So now, thanks to the match statement and thanks to the new validator in our orchestrator, we now know that our agent team successfully responded. So let's go ahead and run this again, just to validate that everything's looking good. Fantastic. So as you can see here, we got the new log, orchestrator was successful, team. We now have the team and Postgres Data Analytics team, engineering costs, 422 tokens. And we now have our clean, where did that go? Agent conversation file here. Fantastic. So a lot more visibility, right? And a lot more confidence. Seems like small changes, we're building out the infrastructure and the kind of system to build out more agentic systems, right? And this is really important. I love AutoGen, and so far it's been really great, but what matters equally is the structures you build around your agents that allows them and allows you to build them out and understand if they're successful or not, and quickly debug, again, keeping that feedback loop as tight as you can. So this is great. We're making some really solid improvements here. So I want to make one more major improvement to our system. So right now our agents are, let's go ahead and look at our agents. The data analyst is kind of just running whatever function that we specify here from anywhere. We have this database Postgres manager getting passed all the way in. And although this works in when we had our data visualization team, we have these like file writer functions. Although this works fine, it's going to turn into a mess over time where you have agents calling arbitrary files, arbitrary functions from all over the place. And on top of that, we're going to want our agents to be able to share information. We have the database file here where we're generating this results.json file. Maybe we want another agent to come in afterward and operate on this data, right? Maybe we want to do some parsing, do some random sampling, etc., right? There are many reasons and use cases you can think of that would really benefit from having a shared store for our agents to refer to. Not only a store, but also a place to call functions and a consolidated, unified place to set up and use explicit functions available to our agents. So right now, we're going to write this centralized class / store that our agents can utilize as their central hub of operations. We're going to call this instruments. Okay, so let's look at our two new classes here. You can see we have agent instruments, and then we have a Postgres agent instruments. And if we dive into this base class here, we can see we have a couple core Python functions. We have an initialize, enter, sync messages, and we have this root directory. The root directory now references a specific path in which our agent system can operate out of. We now have a pointer to our agent file, which uses the root directory. Notice that this is just a base class. We now have the Postgres agent instruments class, which inherits from that and fills out more functionality. So you can think of the agent instruments as a unified tool set for the specific use case of Postgres data analytics multi-agent system, right? So a couple advantages here. All agents have access to the same state and function. This gives our agents awareness of changing context. So we can now store, in the init function here, you can see we now have just information that our agents can use when they're calling their functions, right? So we now have messages, we now have a session ID, we now have any database connections that we want to store. But this is cool because it gives all of our agents really clear and concise functionality. Now our run SQL function, although it does call the underlying DB function, we're now going to have our agents call and use just functionality in the instruments.py file, right? We now have that SQL results, and this is our validator function. On that top level, we have our old data visualization functions here and some new ones that we'll get to in future videos. So this is pretty cool. So if we now look at the top of our main function, we now have two new things going on here. We now are building a session ID, and this is just generating a random session ID. We can now use this to separate our individual runs of our agent systems. And now we're using our Postgres agent instruments. Instead of just using our database, we're now building out this kind of context system called the instruments that our agents can use. So we still have our database, we're also pulling that out. But if we go down here, we can see that we're now passing this in to our build team orchestrators. Now we have agent instruments getting passed in. And now, as you can see, that validate results is coming directly from our agent instruments. So let's hop into the build team. In order to build our agents, we're now passing in the agent instruments, right? So now all of our agents in the data engineering team has access to everything in our Postgres agent instruments class, right? You can think of this as like a reusable context system for your agent. Now our senior data analyst calls this instruments run SQL, right? And it comes right from the instruments file. And it's now available to any one of our agents. Might seem like a little bit of overkill right now, but this is going to be really useful when we're building out our systems. And already I can show you a couple ways that this adds value to our system. So let's go ahead, let's just hop back to the top and rerun our system. So let's run. Now I want to get all auth users failed. Okay, so a couple bugs here. Let's go ahead and fix these. Need to give the prompt here. Go ahead and fix this bug. So as usual, our agents are generating the SQL, and now we're going to run. Okay, so it has no attribute close. Let me go ahead and add this missing function to the database module here. Let's rerun. Okay, great. So now our agent ran successfully. Let's go ahead and look at how our instruments file is helping us. So we're going to add one more thing here. When we build out our orchestrator, we also want our orchestrator itself to have agent instruments inside of its scope for it to utilize. So let's go ahead and just set that. Let's make sure that's right. We're going to call this agent instruments. We can call it instruments. That's fine. Awesome. So now the orchestrator now also has access to the context in which all the agents have as well. So let's go ahead and run this. We can see that we have this new agent results directory, and in it contains our agent chat and our run SQL results. So in this case, we got nothing. Let's see what's going on there. So user ID auth is true and failed equals this. So maybe this is a concrete result. Maybe there's really nothing to be returned here. Let's go ahead and try completed that have status completed. So let's go ahead and run that. But as you can see here, we now have a kind of reusable system that's storing our agent results from session to session, right? From run to run. And this is going to be really valuable when you're comparing the before and after. You want to see what went well on one run and what didn't go well on the other. And so this system, using the instruments, building up specific file directory paths, and I think specifically centralizing all the capabilities that your agents can run is going to be really important for, again, tightening that feedback loop, understanding what your agents are doing, being able to peer into the system. So that's the value prop of the agents. Let's go ahead and watch this prompt complete and generate another, session report for us. All right, let's take a look. Looks like it just completed. Let's take a look at our latest agent results session run. We have the agent chat and we have our run SQL results. If we look at our run SQL results, you can see here we have, looks like all of those users with our, completed status? Yeah, status completed. Awesome. And if we dig into that session ID generation, which is, creating our agent result directory names, it's pretty simple. Basically, we're passing in the raw prompt. We are doing a little bit of just like number parsing, using time to create more unique IDs. Pretty straightforward stuff in here. We're removing spaces, removing some quotes, and then, adding these together. And this has actually been updated since. So this is going to be something like, 22, 33, whatever. It's hours, minutes, seconds there. So that's how we end up with our top level agent names. And this allows us to, again, just keep track of individual runs of our agent pipeline. So that's cool. So kind of a heavy video. I just want to kind of dig in. I really want to show what it's going to take. So just to kind of recap, the value of what we're building here. We built up a really simple way to view our agent conversation. This allows for fast prototyping, fast debugging, fast monitoring, and it's going to be critically important as we scale up our systems. We're going to be referencing this file in future videos pretty regularly as we work through and build our systems and understand the conversation flow, right? So we built out specific validator functions. Let's go ahead and open our instrument and look at these validator functions, right? So you want to know if your agent system is actually doing what it's supposed to do. I think the best way to do this right now is to just concretely run a kind of self-validating function that you can run at the end of your conversation flow to just know that things are working. And then lastly, we centralize all the functionality from our agents into the instruments class. And this allows for a single place for both the orchestrator and the agents to pull and use functionality from, right? So we have the agent instruments here getting passed into the build function. And we also have agent instruments getting used with the validator function. We also have state that we can modify and use throughout the life cycle of our agents calling functions and operations happening while our agents are running. The value of this is really going to show up as we keep building more complex systems. So that's where we're at today, guys. I hope this video was helpful for you. I hope you're starting to see where we can take this. I hope you're really kind of digging into what it's going to take to build out these fully agentic systems. Again, just to reemphasize, the goal of this series, I want to give you the principles and patterns to help you build agentic software. The end state is fully parallel, zero touch, multi-agent systems that work on your behalf. Maybe you type in natural language, you give them a prompt, you give them something to research, something to build, something to analyze, and they just go off, they do it, they produce the outputs, and then they're presented to you in a really clean, seamless way. So what's next for us? We're about halfway through this series. So this is video 5. We're going to deliver 5 more videos, and between now and our last video, we're going to add new multi-agent systems to push our Postgres data analytics even further. I want to build out something where with our queries, it's giving us new ideas and insights on our database that we haven't thought of. So to do that, we're going to need to build new agent teams. We're going to need to build new conversation flows. Then we're going to finally get to putting our agent system behind an API. And once our agent system is there, we can build out a clean user interface to help us interact with our Postgres database and our multi-agent system. If that sounds interesting to you, definitely like, sub, join the journey. We are on the path of becoming agentic engineers. We're trying to go to the next level. Thanks for watching, and I'll see you in the next one.